Hi everyone, welcome to this PySpark data cleansing tutorial. In this video, we will take a messy real-world dataset and transform it into clean, ready-to-use data using just a few powerful PySpark techniques. So let's start. So I'm here in Databricks Free Edition and I have opened the catalog where I would like to create a new schema and get the data set that we need to clean. So for that, you might have already seen in my other video, first we need to add data and I would like to upload it to the volume, and then for that I'll select a catalog and I will create a schema, let's say CSV files. And in that schema, I'm going to create a new managed volume naming CSV files and create. And once we have created this volume, I'll drag and drop the dataset, raw dataset that we are going to use in this video. So now I have actually dropped it here, and let's click on upload. So it has been uploaded. It's not a big file. So let me close this. And now I'll go to the workspace and create a new notebook. Okay. So I have named it data prep, and the first thing when we do the PySpark data cleansing, first thing, if we need to import SparkSession. Like when we start with PySpark, the first thing that we need to do is import SparkSession. Okay. So when we import a Spark session, it actually starts the Spark engine and manages our data. So after importing Spark session, we need to bring in functions, and then functions usually have full of built-in functions for cleaning and transforming columns. And also we import a window which lets us do advanced analytics like ranking, deduplication, time-based filtering, etc. So now let's start with importing those SparkSession functions and window. So here it's already suggesting from PySpark, so I'll just click on tab, and if you look at this from PySpark.sql, import SparkSession, which is good, and then import functions as f, and then PySpark.sql window, we import window as w. So this is what we're going to do in the first step, and let me click on run. Okay, the first step after importing SparkSession functions and window that we need to do is actually we need to initialize. So let me just mark it, initialize SparkSession. So this is the first step, and how we are going to do is we'll actually write spark equal to SparkSession dot builder. So this actually initializes SparkSession builder, and after that we will actually give an app name. So now as you can see, we already get a suggestion app name. So I'll click on tab, and if you look here, It's giving an app named Spark Data Frames. I'll just rename it to Data Cleaning Demo. And after that, I will add one more step which actually initializes or does configuration of time zone. Config spark.sql.session.timezone as UTC. And the last step is to actually get or create function, which actually creates a new Spark session if there is no existing Spark session, or otherwise get an existing one. So this is what we do to initialize a Spark session. And I think we're good, and we can run this. So it ran without any errors. So the next step that we're going to do is we need to load a messy data set. So why this data set is called messy? Because it is actually, if you will see in real life, sometimes the data set that we get for data analytics is always not clean. It might have lots of anomalies, and so something like that we have in this data set, and I'm going to show you after loading it. So the next thing is, so the second step that we're going to do after initializing Spark session is to load messy dataset. And how we're going to do is we will actually read, so using the Spark session we created, Spark, we will use its read function, and we'll also use the option header true and info schema. And after that, okay, so I already suggested, so there is this option header true, info schema true, and with these I will give an option of multi-line to be true, because there can be multi-lines in CSV, and also an escape option, because why we do this, we will actually, what we are doing is we use double quotes to escape special characters. So there can be special characters, so we use double quotes to escape that. And then we need to change this location. So the location is going to be volumes, workspace, CSV files, dataset.csv. So this is actually the location of the file that we dragged and dropped like before, and in catalog. So even if we go and look here under catalog, you should be able to find it here under workspace, CSV files, and then here is the data set. Okay, so this also looks good, so I think let's run this. And okay, so we get the data frame with ID, name, amount, is active, order date, sex, and updated at. So these are the things that we have in our data frame. So now what I'm going to do is actually we'll first inspect the data set. So how we're going to do is raw data. So for this we can make use of df.show function. In PySpark it's actually show, and then I will display its 10 rows and no truncating. So this is one thing, and in addition to that we can also print the schema with its column type, so we can see how they are currently stored. And let me run this. Okay, so here we are. If you look at this, we have a negative amount in amount column, and under the sex column we have actually, there is no specific categorization. I mean, like sometimes it's F, sometimes it's female. So yeah, there are actually many things that you can see here. Okay. And here it's id int, name string, amount is okay, amount is now in string, and is active in string, order date, okay, order date is also string, updated date is also string. Okay, so the print schema helps to see how they are stored currently. So now let's go to the next step. Okay. So first we will actually look at the column names. If you look at the column names, they're not standardized, like there is actually space in between for is and active, order date. So let's try to first standardize this column names. So standardize means we need to sometimes remove spaces, special characters if any, and lowercase is preferred. So these, so it's actually now we are cleaning from the upstream to lower stream. So we start with column names first, and so first let's start with the cleaning up the column names. So that's what we are going to do. So how we are going to do is we will actually, because this involves special characters, some kind of like, so it's helpful if we import this module, which is actually a regular expression module, array, okay. And here I am gonna first initialize a list called new calls to store. This has been created to store clean column names. Okay, so now we will actually have a for loop. So let's say for C is column name in df.columns, what we're going to do is, first thing that we're going to do is we will replace any spaces or hyphens with underscore, and then convert to lowercase. Okay, how we're going to do is new column or nc is equal to re.sub, and so the regular expression or okay, and we will replace this with underscore, and also we will see using the strip function we will change it to lowercase. So this is what we are going to do in the first step. Okay, so I think our expression is good, looks good. Okay, so now the next thing that I'm going to do is, okay, right, so remove any characters that are not alphanumeric or underscores. Okay, for this we'll actually use again this regular expression module re.sub, and check for alphanumeric A to C. Okay, so we will do this, check this on the new column at NC that already we created, and that's it. And the next thing that we're going to do is replace multiple underscores. If there are actually multiple underscores, replace them with just single one, and also strip any leading or trailing underscores. So for this we'll use again re.sub and r. Okay, so replace them with single one, and strip. Okay. Next thing that we're going to do is now we have cleaned. So NC will be having a clean column name, and we will append that column name, clean column name, to the list. So new calls dot append NC. So that's what we're going to do, and this for loop is complete. So next thing that we're going to do is we will replace the old column name, so the current column names with the new ones. So how we're going to do is old new in zip of div.columns, which is actually the current ones, and the new columns. And we will see if old is not equal to new, then df is equal to df dot with column renamed, and we will rename old with new. So this is what we are going to do. Rename old new. Okay, so now let's see how it will turn out. So we'll use the print schema and I'll run this. Okay, so it looks good. We have ID, we have name, everything now in lowercase. We have amount, we have is active, the space is actually replaced with underscore, and then order underscore date, the space again, and then 6, and then update to that is again the space is replaced. So amount dollar, the special characters have been removed, changed. Okay, so I think we have now cleaner column names. So let's see what's going to be the next step. So once we have column names cleaned up, we will use now the values. So we need to actually check, and we need to check column values. So we need to trim any spaces or remove non-breaking spaces and replace if there are values like NA or dashes with proper nulls. So this will help us in data analytics in the later stage. So this is what we are going to do next. We will actually trim spaces and remove any non-breaking spaces and replace NA or dashes. So let's see like how we will start. So first let me create a list that needs to be replaced. So NA tokens. So when it's actually empty, or when it's NA, sorry, this needs to be in double quotes, and then none, null, just dashes, sometimes double dashes, unknown. So these are actually the values or tokens usually representing missing values. So let's use a generic, or actually replace them with null. So what we're going to do is we will actually do a for loop, and we will look at each column and its value. So df dot, first we will check data type, and we will only do this replacement when it's string. So we'll check if type is string. Then df is going to be df dot with column c, and we will use regular expression replace, that is reg exp replace from functions, and we'll use the column c and replace any x. So this is actually for the non-breaking space. We will replace that with regular spaces. Okay, so what we are doing in this step is actually we are like regular spaces. And next thing that we're going to do is we will trim leading and trailing spaces. So we can use the trim function, and how we're going to do is we'll use df with column, and it's c, and f dot trim of f dot column of c. Okay, so this is lowercase f, and we need to replace it with uppercase 1. So next thing that we're going to do is replace multiple spaces, if any, with single space. And for this we will again use the regular expression df dot with column and c comma f dot reg exp replace f dot column of c r space with single one. Okay, so this next thing we will actually replace NA tokens with null. So that's what we're going to do, replace NA tokens null. So how we'll do it, df dot with column and c, and we'll check if first we need to convert that to lowercase to match with that of the list values, and then if we'll check if this value is there in NA tokens, then we will replace it with none or null value, so none. Okay, so I think we get an error somewhere, if not lower. Yeah, we're missing a closing bracket here, and it's actually dot is in NA tokens, then we'll replace it with none. Okay, and if otherwise we will use the same value, so we don't have to replace it. Okay, so I think it's good. So yeah, there's no error. Okay, so now our for loop is complete, and we try to replace non-breaking spaces with regular space, and then trim leading and trailing spaces, replace multiple spaces with single space, replace NA tokens with null. So now it's a time to see how it turned out. So df.show and truncate false. Okay, so let's see. Okay, you can see null value. I think it was null before. Yeah, NA has been replaced with null. And there was this leading space before this amount value, which was actually before 1. It has been removed. So there are those kinds of things that you can actually see in this after doing our 5th step, so trimming spaces and all. So the next step is actually checking the data type, so which we already saw that they are actually not stored in their right format. So now we need to check that. So amount needs to be numbers, and if any boolean, then it needs to be true or false, and dates with proper timestamp, and we need to actually get a unified or actually the same date format for all value or for date values. So when you actually scroll through it, you might be able to see that there will be different from these values. No, but they can be actually, they might be stored in different formats, mixed formats. So even if when we have mixed formats, we need to actually get a single format or change them into a single format. So let's see how we'll do it. So the first thing that we're going to do is amount. So we'll store it as a double value so that we can handle full width digits. So df equal to df dot width column and amount. So we'll use the regular expression, replace and amount. Okay, so the first thing that we're going to do is replace any full width 0 with normal 0. So actually this is a special character, so it can look like this, and what we're going to do is we will actually replace it with regular one or the normal 0. And the next thing that we're going to do is remove any non-numeric or non-comma and non-dot or non-dash characters, so that we have only numbers, proper numbers under amount. So how we do that? We'll actually use df.width column and amount and f dot expression replace amount r Okay, and we'll replace that with space. Okay, and next thing that we're going to do is let's so sometimes, like in some formats, especially in Europe and all, 1000 separators are usually period, so we're going to remove that and use replace that with comma. Again with column, amount, express replace, amount, or okay, we'll replace it with empty, or actually not going to replace it with comma, but we'll actually just remove that. Okay, the next thing is actually okay, so for the decimal space, we may see if you see, look at here, it's using comma for decimal space, and we will use dot to have a standard format. df equal to df width column amount f dot reg expression replace, so amount, and we'll change this comma to dot. Okay, and next thing is we'll now change its data type or convert to double. So it's already prompted. How we are going to do is we'll use df equal to df dot with column, and then amount f dot column amount dot cast to double type. So okay, so after doing this, let's try to do this df dot show truncate equal to false. Okay, so if you look at that, we don't have any 1000 separators now, and then decimal space we used comma before, now replaced with dot. So yeah, I think those are the things that we can see from these top 10 rows. Okay, so I think we can move on to the next step for boolean. So let's say like we have this is active column, so we will actually change that to boolean is active column. How we are going to do is df equal to df dot with column, and it's is active. Okay, and we will use a when function. So when f dot lower of is active. So first we will replace all the truth values to, okay, let me map truth or truthy values to true. So that's what f dot lower is active dot is in. So we'll have a list of values to match with. So we have it's true, then t, comma yes, y, then it can have value 1, then it can have value active. So these all values can actually can be there for these truthy values, and we're going to replace them with true. Okay, so this is what we're going to do in this. At the same time, we need to actually map all the falsy values to false. So we'll use when f.lower is active. So it has already suggested based on what we have for true, and it looks good, is in false, f no, n 0 inactive, and f.lit to false. Okay, so we need to add one more condition, that is if it's otherwise, we will actually give it none or the null value. Okay. Okay. Set all other values to null. Okay. So we have done it for is active. So let's see after how it looks. Okay, so we can see that we have those values are now replaced with false and true, and it's actually now it is a boolean. So is active is boolean, amount is double. Okay, that's great. Now we need to do with the dates. So there are actually two date part. So first one is order date, and then updated at. So first we use the f dot, so it's okay. Okay, so the first thing that we need to do is there can be some leading or trailing spaces, which we already removed, tried to remove in the other before with the column values, but it was okay, string type, but still we'll actually do it here, trim spaces. So df equal to df dot with column, so order date, and let's use f dot trim, call f dot order date. Okay, so we are done with the first step, and the next thing that we're going to do is we will use date separator as this one. So sometimes there can be date separators used. I mean, like hyphen is also a data separator, which is usually common. So now what we're going to do is we will actually replace hyphen with backslash. Okay, sorry, no, backslash, forward slash. Okay, df equal to df dot okay, df dot with column order date, and yes, f dot regex replace call of order date column date, Okay, hyphen or dot with forward slash. Okay, so the next thing is fill missing time only if date exists. So they can be like, sometimes we won't have the date, or sorry, the timestamp with it. So we will actually, when there is already a date value, if it's not null, then we are going to fill that timestamp field. Okay, so how do we fill it? We'll actually append 0000 if time is missing and date value exists. Okay, so how we are going to do is df dot with column and then order date, so we'll check if when call order date dot is not null, and there exists a date value. So how we're going to do is we'll actually use f dot call of order date dot r like. Okay, so r, so it's going to be a big expression, date t 1, 2. Here, space, then for the minutes. Okay, so I think we are good. It's actually d12 and then forward slash d12 d4. Okay, this looks like a date format, and we will correct if there are any mistakes later. Okay, so if there is this date part exists and there is no timestamp, then what we're going to do is we will actually replace space value with order date zero zero zero. Okay, and otherwise we will actually just keep it as it is. Order date Okay. Okay. Otherwise, yes, when, okay. Okay, so one step here, sorry. So what we're going to do is we will actually parse. So we'll see if all dates follow same format, and invalid formats will be changed to null value. Okay, so div equal to div dot with column order date. So we'll create a new column called order date timestamp, and for this we'll actually use if dot expression. So we'll actually change it to try to timestamp. So when we use this try to timestamp instead of to timestamp, when there are invalid formats, it will actually convert that value to null. So that's actually the benefit of try to timestamp instead of to timestamp, because if we use only to timestamp, then it will actually throw an error if it finds some values which are in invalid format. So we use here invalid, sorry, try to timestamp, and this is actually the format that is now it has currently. Okay, so now the step is, now we have it in the m /d /yyyy, and instead of that what we are going to do is we will change that to yyyy. So this is actually the common format that you might have seen in database or SQL servers, or so this is actually the common standard format, and we will try to parse, or we will format timestamp as YYY, DD, and MM. So for that, what we need to do is do if dot with column and order date. Okay, so what has been suggested looks good. But I'll just need to add one more check here to check if the column has values. If it's not null, then we will use this. Otherwise, what we're going to do is we will actually use none, and we can now drop the new or the redundant column that we use, order date TS. Okay, so I think now we should be having the dates value, and we will do okay. So here when we look at the output, it looks a bit odd. It looks like we have got somewhere wrong, and it's always, this is actually a mistake that I did. It's like it's always good to do the output printing after each step so that we can know whether we are actually going ahead or moving in the right direction. And here that's where we got it wrong, so it looks like somewhere it went wrong and I'm trying to figure out where it is. So now I have actually added this print after each step. So now let's try to run all, because we have like now the order date has been, it's a wrong data, it has wrong data, so it's better to run all and see where we are. Okay, so now we have some so the first step looks fine, second step looks fine. Okay, so the third step, after each even the timestamp 000 gets added, even there exists a timestamp field, so that looks a bit odd. So let's look at the third step, step 3, missing filling time, append 00 time if it's missing. So with column order date, and when order date is not null, and we need to check if it's matches this expression. So this is for the date field. Okay, the first two, it's actually like date. Okay, and it's actually for the month. Okay, because we see at 1/22 here, so it's 1, 2, and then 1 to 2, and then 4 for the year, and then here we have for the hours. Okay, so yes, I think instead of 2, I actually wrote, or I typed 20. So I think that's where, because it's not matching this expression, so it's actually looking at the 20 characters or something, so it's giving it's not matching, and it actually goes to the concat. So when it's not matching, so I think now we should be good. So what we can do is we can do run all. Okay, so now even the end output looks fine, which is actually this YYYMMDD, and if we scroll above, so I think that was actually where the mistake was. So I think we are good here, and I'll comment all these parts in order to avoid. Okay, so great. So I can run it again. Oh, sorry, run all. Sorry, because we already did all the changes, so I'll run all. Okay, so now we have it good. So order date looks good, and it's still in string format. And now what we need to do is we need to repeat the same for updated at, and it's going to be easy. So what we need to do is we just need to copy paste that code and replace order date with updated at. Okay, so we'll start replacing. Okay, so now we have changed updated at. Okay, yes, this part didn't change. I don't know why. Okay, so I think run all. So here, so the next step that we're going to do is based on this updated at. It's like actually because there can be, we always need to keep the latest record based on the updated at timestamp. We can remove duplicates if there exist any duplicates. So that like we can avoid any redundant data. So how we are going to do is we will actually deduplicate. So the step is going to be 7th. So what we're going to do is we remove duplicates. Based on updated at timestamp. Okay. So here, let's say like because ID is going to be the unique or the primary key, we will actually assign, let's say primary key PK is going to be ID. Okay. And we check if updated at in df.columns, if there exists an updated at, and then what we are going to do is we will let's say we will define window. So what we're going to do is we will partition. So this actually applies the same logic as in Excel. So when we use window functions, we actually do the partition, and here we do the partition by primary key and then order by updated at in descending. Okay, so how we are going to do, we actually use w equal to w dot partition by, and it's going to be pk dot order by column updated at, and we'll order it by descending. Okay. So the next thing that we're going to do is we will add a row number within each primary key partition and keep only the latest row, so that we won't have any duplicates. So we'll also drop temporary row number column after that. Okay, so how we are going to do is we'll use df dot with column, and we'll use a temporary column called row number, and it's going to be f dot row number over w, and it's going to be where f dot, so the row number is going to be 1, because after the ordering by sorting by descending, and when it's 1 we'll keep it, otherwise we will drop it. So no, not otherwise, actually, like after doing everything we will drop that column. Okay, okay, so here we are. What we're doing is we will maybe so what we do is we will add a row number for each partition. So that's what we could do. We are doing f dot row number over w, and then we will check where its number is 1, So we'll keep only the latest row, and once we are done, we will actually drop that column because we won't need it again. And then we can also use so let's say if we don't have it, okay, the next step when we do else for this if, so what it checks is if updated at doesn't exist, then we will drop duplicates based only on primary key, because then there is nothing to be checked whether it's latest or not. So when there is no updated at, then we will drop all the duplicates based on df equal to df dot drop duplicates function using pk. Okay, so here we are after the deduplication step, and let's print and see if we get okay, because we don't have any okay, so now it's ordered and we should have only one column or one row per primary key or the ID. Okay, so now we are done with deduplication part, and now what we need to do is normalization or the normalized categories for this column 6. So the next thing is it's going to be 8 and normalize categories. So what we need to do is we need to actually 6 column values, like let's say there is actually M, there is male, then there is female, are unified into consistent categories. So that's what we need to clean that column up. So how we are going to do is we'll actually do a mapping. So define mapping to standardized values. So let's say M equal to so now we are listing all kinds of possible combinations. M, then male, similarly F, female, female to, then we can have other, to other. Okay, so even if we look here, we have null, which is fine, MF, so the small letter, capital letter, okay. So the small letter, small letter, capital letter of this M and M that we can take care later using the lower key, so which is fine. So now we have defined mapping. Now what we need to do is we need to create a map expression. So how we going to do is max expression equal to f dot create map. So this is a function that we're going to use, and then we will check if f dot let x for, let's say, key values in m dot items for x in key values. So what it does, this function is actually creating a mapping, so that actually like for each, so if it's M, it's actually going to map to a male. If it's a male, then it's going to map to male. So it's checking each key value pair in this one and then mapping to the correspondent value when we use it in any expression. So the next thing that we are going to do is we will, using map, we will normalize the column. Okay, and how we do it, df dot with column, and here the column is 6, and then f dot coilies. So because f dot element art is something that we can use for the mapping, and then we will check for each value of, so lowercase value of sex column, and if it's matching then we'll use it, otherwise we will use the value which already exists. So let's say in case of null, so we'll keep it as it is, so that like we don't have to do any mapping for that. Okay, so that's what we do, and after this let's try to show. Okay, okay, great, we get some male, author, other, so let's say like it was other, and otherwise it looks good. There is null and then male, female, so which is actually now it looks good. We have some standard values, so I think we are kind of good with column values. So now the next thing, or the next step that we can do is kind of, it's a little bit, I would say, advanced than basic cleansing up of data. So I will make it, I'll show you like a simple example. So what we do is we will handle outliers. So in this this amount column, you can see that there can be actually a lot of values which may lie outside of a reasonable range. So what we are trying to do is we will actually get an approximate 25th and 75th percentiles for that column values, and later we will actually define lower and upper bounds. So if any outliers, then we will actually cap them. So that's what we're going to do, and how we're going to handle it is, first, like I mentioned, the first step is to compute approximate, let's say approximate 25th and 75th percentiles, that is actually Q1 and Q3 of column amount. Okay, so let's say Q1 comma Q3 equal to df dot approx quantile, and then we have amount, so it's already giving suggestion, so it's actually 0.25 comma 0.75, and then we will actually give 0.01, let's say. Okay, so if you're already not familiar with approx quantile, it actually, if you look at here, it actually gives you that 0.01 is the value that relative error. So how much kind of like error can happen from the exact value. So it's a tolerance kind of level, relative error. So it's like the return quantile values may differ from the exact ones by up to 1%, which 1% is actually 0.01. So more accurate. So that's why. So that's what it is actually like giving here. And after this step, the next step is we need to calculate an interquartile range based on this Q3 and Q1. So how we calculated interquartile range, IQR is equal to Q3 minus Q1. Yes. And also we need to define lower and upper bounds for outliers. Let's say we will actually define it as 1.5 into this IQR value. So that's a rule that we're going to apply. And let's say like we have lower value and higher value, which is going to be Q1 minus 1.5 into IQR. Then it's going to be the lower value, and Q3 higher upper value is going to be Q3 plus 1.5 into IQR. Okay, so next thing we need to check if values fall in range, and if yes, then keep them. Okay, so that's what we're going to do. df equal to df dot width column, and we're going to use a new column called amount kept. And next thing that we're going to do is f dot when f dot call of amount is going to be lesser than LO, then keep LO. And if when f dot call of amount is greater than high, then keep high. Okay, and if otherwise, what we're going to do is we'll okay, so let me try to make this clear. So actually what we are trying to do is, if value lies below LO, the range, and then we will actually set it to LO, because we won't need any values below LO. And if value lies above high, and then what we're going to do, we will set it to high. Okay, and otherwise that means it falls in the range, we'll keep that value. Okay, yeah, so that means we're good. And then we will df.show 10 truncate equal to false. Okay, let me run this. Okay, so if you look at amount and amount kept, so we know that most of the values look fine. And then this negative 5,000, which looks, of course, it looks odd, and it has been changed to negative 2987. So why? Because this is actually the lower value, and we don't need any values because it's an outlier. And then we will keep it to the LO value, which is negative 2987. So that's what's happening here. So yeah, I think now we are in this step. We try to handle outliers, and we first defined and 25th and 75th percentile, and then defined an interquartile range, and then based on that we define lower and upper bounds. So anything that lies below lower, then we kept it to the lower bound, and then or the range value, and then if the same case with the upper bound, and then if anything false lies within the range, then it's good. So here we have actually kind of done an outlier handling, okay, or notebook that you have seen. And now the last step we are going to do is, after cleaning up our data set, it's a time to save it. And we will save it as a table. So now, last step, save as a delta table for further processing. And how we do it, df.write.format, and then it's delta, and the mode is going to be overwrite, and we will use option of merge schema to be true, and save as table. So here we have CSV files dot processed data. Okay, so let's run. And that's it. If we look at the catalog, we have my organization, and when we refresh it, CSV file, so there is this table which is called process data, and we have all these different column set values. So yeah, I think that's it. Thanks for watching, and let me know whether you like this video or what kind of more information you would like me to add, and please let me know in your comments. Thank you so much.